Today we're going to be solving absolute value equations and inequalities. This is section 1.4 in the Algebra 2 book. An absolute value equation and inequality always has two solutions. That is because absolute value is your distance away from zero, and you can go to the left to get a distance away from zero on a number line, or you can go to the right to get a certain distance away from zero on a number line. So in this first example, we have the absolute value of x plus 5 equals 12. That means I can go 12 units to the left of 0, or I can go 12 units to the right of 0. So x plus 5 could be equal to 12, or x plus 5 could be equal to negative 12. Subtract 5 from 12 in each equation. 7 is what we get for x in the first one. Negative 17 is equal to x in the second one. Always check your answers to make sure both of your answers work. Sometimes one of them won't work, or even both of them won't work. They work for this one, so 7 and negative 17 are both answers to the equation. Example 2. We have absolute value of x minus 1 equals 7x minus 13. Our first equation is going to look just the same. X minus 1 equals 7x minus 13. In the second equation, leave the x minus 1 the same, but change the sign of the 7x and change the sign of the 13. So it'll be equal to negative 7x and plus 13. We're going to solve for x in both equations. We begin by adding 1 to the right in both equations. And now in the first equation, we're going to subtract 7x to the left, but in the second equation, you're going to add 7x to the left. Now in the first equation, you're going to divide by negative 6. In the second equation, you're going to divide by 8. So 2 and 1.75 are two answers. Always go back and check your answer. When you plug in 2, it works out just fine. 2 minus 1 is 1. 7 times 2 is 14. Minus 13 is 1. You get the same answer on both sides. However, when you plug in 1.75, you get a negative on the left side of the equation. Inside, the absolute value will turn positive, but on the right side of the equation, it stays negative, and a positive does not equal a negative, and therefore, when you plug in 1.75, it didn't work. So that answer needs to be crossed out and forgotten. The only answer that we have is the first one, x equals 2. Try example 3. Make sure that you isolate the absolute value before you begin. Get the absolute value by itself before you write your two equations. Okay, we're going to begin example 3 by subtracting 1 to get 16. We're going to divide by 2 to get 8. And now we write our two equations. We're saying 5x plus 3 equals 8, or 5x plus 3 equals negative 8. And again, that's because you can go 8 units to the right of 0, or you can go negative 8 units to the left of 0 to still have the same absolute value. In both equations, you're going to now subtract 3. And in both equations, you're going to divide by 5. So the first answer we get for x is 1. The second answer we get is negative 2.2. And when you plug both of them back into the original equation, they both work out correctly. So this one has two answers. Try example 4 and pause the video until you're ready. In example 4, we're going to keep the 6x plus 7 equals 5x plus 2 the same in the first equation. And the second equation, keep 6x plus 7 the same, but change the sign of the 5x to a negative, change the sign of a 2 to a negative. So it would be 6x plus 7 equals negative 5x minus 2. Now we're going to solve for x in each equation by beginning by subtracting 7 to the right of each equation. And in the first equation, you're going to subtract 5x to the left, but in the second equation, you're going to add 5x to the left. The first equation is done. We got x equals negative 5. The second equation, you have to divide by 11, and you get negative 9 over 11. Now check your answers to make sure they work. When you plug back in negative 5, we get a negative number on the left side of the equation, which the absolute value of that turns it positive. But on the right side of the equation, you keep the negative number, and therefore the positive doesn't equal the negative. So negative 5 does not work when you plug it back in. When you plug in negative 9/11ths, you again get a negative number on the left side that turns positive because of the absolute value. On the right side of the equation, you get a negative answer. It stays negative. So positive doesn't equal the negative. That answer doesn't work either. When both of your answers cross out and don't work after plugging them in, then the final answer would be no solution. Dealing with inequalities. When you write your two equations for the inequality, You want to make sure that you flip the sign of the inequality on the second equation as you make the number negative. So the first equation is going to look like 3x plus 2 is greater than or equal to 4. That's going to stay exactly the same. On the second equation, as you make the 4 negative, you change the greater than sign to a less than or equal to sign. So that equation is 3x plus 2 is less than or equal to negative 4. Subtract 2 from both sides in each equation. And now divide by 3 in each equation. And so we get x is greater than or equal to 2/3 for the first one, x is less than or equal to negative 2 for the second one. Both of those answers work when you plug in a number greater than 2/3 and you plug a number less than negative 2 in. Both work into the original problem. Try the last one. First, isolate the absolute value by dividing by 2 before you start writing your two equations. Okay, we're going to begin by dividing by 2 to get 7. And now we write our two equations. In the first one, we're going to say x minus 5 is less than 7. In the second equation, we're going to change it to a greater than and change it to a negative 7. So x minus 5 is greater than negative 7. Add 5 to the right side of the equation in both. And we get x is less than 12 for the first one, x is greater than negative 2 for the second one. Both of these answers work out when you plug a number less than 12 in or you plug a number greater than negative 2 in. It works into the original problem, so both answers are legit.